Have you ever noticed your computer slowing down to a crawl when you have too many apps open? It's like everything just freezes up. What's actually happening inside your machine? Today, we're going to demystify this common problem using a simple analogy, a busy shipping port. Imagine your computer's RAM, or random access memory, is a premium dockside warehouse. It's super fast right next to the ships, making it perfect for loading and unloading cargo quickly. This cargo represents the apps and data you're actively using. When you open an app, say a web browser, its data is loaded into this dockside warehouse, ready for immediate use. Everything runs smoothly as long as there's space. Now, let's say you're a multitasking pro. You open your browser, a video editor, a music player, a messaging app, and a dozen other things. Soon, your dockside warehouse, the RAM, is completely full, no more space. But you still need to open one more program. What does your computer's operating system do? It can't just say no. This is where a clever trick called virtual memory comes into play. Think of virtual memory as a backup plan. The system has another, much larger warehouse, but it's far away from the docks. This is your hard drive or SSD. It has tons of space, but it's a lot slower to get to. When the dockside warehouse gets full, the warehouse manager, your operating system, looks for cargo that hasn't been used in a while. Maybe it's that browser tab you opened 2 hours ago and forgot about. The system then takes this inactive cargo and moves it from the fast dockside warehouse back to the slow, remote warehouse. This process is called swapping, or sometimes paging. It frees up precious space in your RAM, allowing your new program to load and run. On paper, this sounds like a brilliant solution, right? You get to run more apps than your physical RAM should allow. But here's the catch. Remember how I said the remote warehouse is slow? Moving data back and forth between the fast RAM and the slow hard drive takes a lot of time and effort. This is the swapping process in action, and it's the reason your computer starts to feel sluggish. Every time you switch back to an app that was swapped out, the system has to go all the way to the remote warehouse, find that data, and haul it all the way back to the dockside warehouse. This journey causes a noticeable delay. You click, and you wait, and wait. That lag you feel is the cost of swapping. Your computer is spending more time moving data around than actually executing your commands. Now what happens if this goes on for too long? What if you have so many apps open that the system is constantly moving data back and forth, with no end in sight? This leads to a catastrophic state known as thrashing. Picture our warehouse manager in a total panic. The dockside warehouse is always full. To load new cargo, they have to move old cargo out. But as soon as they move it out, someone needs it again. So they have to bring it right back, which means moving something else out. The manager is now spending 100% of their time just shuffling boxes between the two warehouses. No actual work is getting done. No cargo is being processed for the ships. The entire port grinds to a halt. This is thrashing. Your computer becomes so consumed with swapping data between RAM and the hard drive that it has almost zero processing power left to run your applications. The system is technically running, but from your perspective, it's completely frozen. The hard drive activity light is blinking like crazy. You can probably hear it working overtime, but your mouse cursor is stuck, and nothing on the screen is responding. It's the digital equivalent of a total system meltdown, so how do you solve this? The simplest solution is to add more RAM. It's like expanding your dockside warehouse. With more space right by the docks, you can keep more apps and data readily available without needing to constantly shuttle things to the remote storage. It's the most direct way to reduce swapping and prevent thrashing. Another way is to simply be more mindful of how many applications you have running at once. Closing programs you're not actively using frees up that valuable RAM space and keeps your system running smoothly. Now, we've talked about the RAM as the dockside warehouse, the hard drive as the remote warehouse, and the operating system as the warehouse manager. But there's a crucial player we haven't mentioned yet, the CPU, or the central processing unit. In our analogy, the CPU is like the team of highly skilled dock workers who actually process the cargo. They run the calculations, execute the instructions, and make everything happen. So here is a question for you to think about. How is the CPU involved in this whole chain of command? What is its role when the system starts swapping data? Does it just sit and wait while the warehouse manager moves boxes around? Or is it actively involved in the process? Understanding the CPU's role is key to grasping the full picture of how your computer manages its resources. Let me know your thoughts in the comments below. What do you think the CPU is doing during all this swapping and potential thrashing? I'm really curious to see your explanations and analogies. We can explore that in a future video. Thanks for watching, and if you found this helpful, don't forget to like, subscribe, and hit that notification bell for more tech deep dives. See you in the next one.